I've got to install some 4 feet T-8 LED lamps in a panel that is only 3 inches deep. Another little item, the T-8 lamps themselves need to be at least dust sealed from the panel it's mounted in. Finding an off-the-shelf fixture has not been fruitful, so I've done a bit of testing to see what I can make a fixture out of. I think I've found what I need. What I'm going to try and use is an aluminum composite material. It's 2 thin sheets of painted aluminum with a polyethylene center core. This stuff is pretty rigid. It's made for use in signs and stuff like that. The only real problem I see with it is that almost nothing sticks to the core material. But good construction adhesives do seem to stick very well to the painted surface. So I've got some scrap pieces to test on. I actually have enough of these pieces to make the 6 fixtures I need if I don't screw up too much. Some of the pieces are a bit bowed, so that is going to add a bit of a challenge. So I'm going to cut 4 grooves into the sheet. Each groove is cut with a 60-degree V-cut bit. I should end up with a fixture that is 4.6 inches wide, 2.25 inches tall, and 48.375 inches long. I'm hopeful. The outer 2 cuts will cut all the way through the sheet, making the outside long edges of the fixture. The inner 2 cuts will leave the aluminum and a couple hundredths of the plastic core. The panel will be bent at these cuts. Cutting all the way to the aluminum didn't work out so well. Now the bow in the pieces may have contributed to that failing. The V-cut bit does leave a lot of little pieces of plastic stuck in the groove. They're thin, but I want them out of there. Running over the sides and bottom with a small flat blade screwdriver seems to do a good job of cleaning up the grooves. Even though the aluminum is only about 8/1000ths of an inch thick, the cut edges have a pretty good burr on them. Again, the V-cut bit, not the greatest clean cutting bit shape. I'll go over the edges with some 120 grit sandpaper. It's not really a problem, but spending a few minutes sanding the edges will for the most part eliminate the chances of me getting cut on the edge, and me not getting cut is worth it. This stuff has a tough plastic film protecting the surface. While the paint on it is very nice, it can be scratched pretty easily if anything sharp scrapes across it. It is a pretty dense material, but it does dent. Probably about like poplar wood, maybe a bit tougher. On my first test, I cut the groove all the way down to the aluminum. Really made it easy to bend, but the aluminum is just too thin. It was really weak. So for these, I've left a little over 2/100ths of an inch of plastic, and that really makes them tough to bend. And if the plastic is cold, it will break at the groove instead of bending, and then it's ruined. So I'm going to heat the area of the bend. Now I have the heat gun set for 700 degrees. It's slow going, but with the heat set that low, I haven't burnt any paint or blistered the plastic that I know of. Even though the aluminum is thin, it is still quite good at spreading the heat out over the entire area. So the first bend is going to require a longer heat time. That's about as much as I'm going to get by hand. So I'll move the panel up in the clamps to do the second bend. I'll heat the bend area for about a minute, then start the bend. I'll heat and bend for another minute or so. I'm not going to get near the final form like this. This is just to get the initial shape so I can put it in some clamps. I'm going to use 4 bar clamps to squeeze it into shape, basically saving my arms and hands from being worn slap out. After the initial bends, it's about 5.8 inches wide. The finished width should be about 4.6 inches, so I've got 1.2 inches to make up for. Now it's just heat up the bends, then tighten the clamp. I'll focus the heat in an area around the clamp, getting the aluminum quite a bit hotter than the initial bends. And I'll repeat this over and over and over again. I did this process for about 10 minutes, but I was being overly careful. I end up getting 6 panels cut out, so if I break one, I've got to get a new sheet of this stuff. For the last bend step, I will clamp the width to 4.58 to 4.59 inches. It takes quite a bit of clamp pressure to achieve that width. The angle cuts are touching at this point, so I'm actually bending the panels a bit at this distance. After it's clamped to that width, I will put quite a bit of heat to it. This will be the hottest I get the aluminum. Even a couple seconds after removing the hot air, I can't touch the bend. Well, can't touch it without pain. To get it that hot, I'll move the heat gun very slowly over the bend. I think I'm moving around 1/4 inch a second, maybe a little less. But the speed will depend on how much heat is coming out of the end of the heat gun. I'll leave the clamps in place till it cools. Doesn't take but a few minutes. Aluminum is a great heat sink. The end caps are made of the same material. I'm cutting the grooves with a 1/4 inch bit. The depth of the cut is about halfway through the 6mm sheet thickness. The grooves at a 1/4 inch wide will give a tiny bit of clearance for the 6mm panel to fit into. With the glue, it will still be a tight fit. I have to do a bit of touch-up for the end caps. Basically, I was too lazy to go back and redo the G-code and cut out a new set. Again, I'll sand the edges just to take the sharp bits off. The O-flute spiral cutter cuts a much cleaner edge than the V-cut bit. Really leaves an even sharper edge, but really no burr. And I will hit the groove a tiny bit, just to give it a rougher finish for the construction adhesive. I will rough up the inside and outside ends of the bent panel with the same sandpaper. Same reason. Then clean all the mating surfaces with some isopropyl alcohol. The cheaper construction adhesives didn't seem to hold very well on the panel surface. This PL and the Gorilla Glue construction adhesive both seem to work well, only I'm out of the Gorilla Glue, so I'll use the very difficult to clean up polyurethane. I want to use enough that it has to squeeze out. It may be the bulk of the holding strength is where the adhesive contacts the aluminum, and that is going to be where it comes out around the edges. It is definitely a tight fit, but that's good. The fixture is going to be held by the brackets mounted on the end pieces, so even if the glue fails, it really can't slide out of the end pieces. After both end pieces are in place, I'll put a bit of tape over where the glue will squeeze out. I don't want this stuff getting on my clamps. I'm clamping it very lightly, not enough to flex the fixture, but enough that I can pick up the light fixture and the clamp will not fall off. I will let the adhesive set overnight before I install the T8 sockets. These sockets have a 5/32 inch slot in them, which works out great. I'll drill a 5/32 inch hole for a 5/32 inch rivet. One thing is for sure, this stuff is very easy to drill. I'll deburr the hole. I mainly want to remove the burrs and scrape any paint off the edges of the hole. I especially don't want to taper on the inside hole. Doesn't matter for the backside. I want the rivet to electrically connect the two sides of the ACM sheet. I had to end up ordering some 5/32 by 5/8 inch rivets. Not that common a size apparently. But that seems to be about the perfect length to mount these. The rivet will just squeeze into the crevices of the slot in the socket. And it seems to be plenty strong. I tested pulling the socket from the rivet. It just busted the plastic away, so I don't think that is going anywhere. The light-facing surfaces are metal, and there is always the possibility, no matter how remote, that one of the lamp sockets could short to the metal. So I'm going to ground all the metal faces of the ACM. Now the back and the front center are already connected by the rivets holding the sockets in. And the front center section, where the socket is mounted, would certainly be the most likely surface the socket would short to. I'm going to attach a ground wire to the back, so I'm putting a rivet in the center of the back, and this will be for the ground wire. I'm also putting a rivet through each angled side connecting the front side to the back. I'll deburr the holes, exposing a bit more aluminum. For these, I'm also going to scrape a bit of the paint off the aluminum. Maybe increase the electrical contact area with the rivet a bit. For the angle sides, they just get a rivet to connect the two sides, and that is all this rivet does, make an electrical connection. For the center, I've got to attach the ground wire, so the wire is placed in between the aluminum surface and a washer. The rivet here is not really contacting the back panel. Hopefully the wire is. This is where a third hand would really come in handy. That should tie everything together. If a socket shorts out, should blow a fuse, and will eliminate any possible static charge buildup. Of course, power has to be routed to the sockets. So I'm drilling a small hole just a bit larger than the wire. I'll seal it up later if I need to. Now instead of exposing aluminum, I'm using the countersink to remove aluminum from around the hole. I want to give a bit of clearance between the aluminum and the wire. I'll do that on both sides. I'll also take some sandpaper and really smooth the area around the hole. Absolutely no sharp edges that could wear a spot in the wire's insulation. I'll run the wire through the hole. With plenty of extra to have a nice soft bend to make it easy to push into the socket. I think that makes a pretty good built-in wire grommet. I'll leave a bit of a curve in the wire as it goes through the hole. No need to put a really sharp bend in it. I will put in a jumper so that both pins of the socket are connected. Not needed for the LED lamps that are going into these, but just in case. I'll tape the wire down with some glass electrical tape. I'm not using this tape for its high temperature properties. It just really sticks great to the ACM. Running all the wires out at one end of the fixture. Going to check and make sure ground is good. That's good. Ground wire is connected to everything. Well, not quite everything. The two end pieces are not yet connected. The mounting brackets are going to be two pieces of angle aluminum. They will get riveted to the end pieces, and the brackets will get screwed to ground. Then everything will be grounded. One last test. I don't expect much of a temperature rise, but I do want to double check. So about worst case, the front all closed up so most of the heat will rise right through the fixture. And I'm going to position the temperature probe over where the electronics are in the LED lamp. Should be about the hottest spot. Now after a little over an hour, it seems to have stabilized. At say a 6 degrees centigrade temperature rise, that's not going to cause me any problems at all. I've got light and very little heat, so I think I'm done. Thank you for watching.